Session 2.3, visualizing variation in categorical variables. So for these sessions, we go back to the categorical variables. Last session, session 2.2, we talk about the numerical data, okay? So for the categorical data, the first one, we're gonna learn the bar chart, okay, bar chart, which is categorical variables similar to the numerical variables. The bar chart, similar to histogram, record the data characteristics along the horizontal axis with the height corresponding to the frequency of the data. So I show you guys an example. Here's the bar chart for the class standing of students interested in the UCLA statistic class. So we do have the class here. This is a category. And the frequency, okay? Remember how to find the frequency here? What's the formula? Use the frequency divided by sum of all frequency. So the first one, that will be 7 divided by 20. You're gonna get 0.35. I want you guys use a calculator, calculate the relative frequency, and then find out the sum of all relative frequency. Okay, check your work. And then this is 3 divided by 20, 4 divided by 20. Okay, right? And remember, what is the sum of all relative frequency equal to? That will be close to 1. Okay, close to 1 here. And then we're gonna, based on this example, we're gonna be construct the bar graph. Okay, I'm gonna show you the answer here, the bar graph. The class, this is the category. We just write it down here. And then on the y-axis, you can use the frequency or you can use the relative frequency. Okay, and then you may ask, hey, what is the difference between the bar chart and the histogram? First, bar chart is specific for categorical data. Okay, histogram is specific for the numerical data. Second, bar graph, they do have a gap in between. Okay, you could see there's a gap in each of the category. But for the histogram, the rectangle is gonna be consecutive, will be next to each other. There's a no gap in between in the histogram. Okay, but both of them, you could use the frequency or relative frequency. And sometimes we like to use the relative frequency. This is really good for your presentation. For example, relative frequency, if I multiply by 100, that will become the percentage. Like this guy. When I'm doing the presentation, I would say, hey, we do have a 5% of the student graduate. And then we do have a 20% of the students are junior. And 25% will be the senior. Okay? It will be easier for you to present it with the percentage. Oh, I just told you guys what's the difference between the histogram and the bar graph, right? Try to answer this one, and then we're gonna try to work together. Okay, let's check the work. The bar graph may touch, okay? You may see some histogram for the bar, they don't touch each other. But usually, most of the histogram, the rectangle is gonna be consecutive and touching each other. The bar graph do not touch, okay? Just like this one, okay? They do have a gap in between. The bar width histogram corresponds to bin width. Okay, remember we could change the bin width. It can show more details or less details. For the bar graph, can be any distort width, all the same. Okay, it doesn't really matter for the bar graph here. Okay, it just makes sure they do have the same width for each of them. Horizontal labels. Histogram is going to be numerical order because we are working on the numerical data, right? For the bar graph, no inherent order. It doesn't matter which one you're going to put it first. Okay, look at this example here. So it doesn't matter, you could put the junior first or unknown first. Okay, the order doesn't really matter for the bar graph. Okay, next one. This is called the parental chart. Okay, parental chart is a bar graph in which the bars are arranged from the tallest to the shortest. Okay, it's exactly the same thing. The only difference between the parental chart and the bar graph is you have to put the tallest bar on the left, and then you're gonna put it in order like here. Okay, this is a parental chart. Okay, last one, the pie chart. A circle divided into pieces. The area of each piece is proportional to the relative frequency or percent or the data in that piece. So look at the example. Okay, I use the same example. Okay, interested in a UCLA statistic class. We know the frequency, we already find the relative frequency. Now I need to calculate the size of a sector. Okay? So this is the pie chart. So for the circle, we do have a 360 degree. And then we're gonna use the relative frequency times the 360 degree. So that will be 126 degree. Okay, I want you guys try to calculate the size of the sector. And then add it all up to see what you're gonna get for the total. Okay, check your work. Okay, when you add it all up, it has to be equal to 360 degree. Okay, and then based on the size of the sector, you could use the protractor to construct the pie chart. You could see something like that one. Okay, so the advantage to using the pie chart is you could summarize a large data set in a visual form. When I look at it, I could easily compare 2 or 3 more of the data, right? And disadvantage, you could say need to draw by hand is really hard, right? Because you need the protractor, you need to calculate the size of the sector for each of them. And then you're gonna use the protractor to find it out the degree. And sometimes we could use the percentage. Sometimes the people construct the pie chart, we put the percentage in here, like the unknown, that'll be 35%, and then the graduate here, that'll be 5%. Sometimes they put the percentage here and also, but this is not easily reveal the exact value. Okay, we can't really look at the frequency numbers in here. Okay,